Yeah, we're going to switch gears a little bit from doing our typical probability, and we're going to talk about how we can determine the possible number of outcomes using some different types of counting principles. So the first one is the fundamental counting rule, and we have this definition here, but I think it's best maybe to start with the example. So we have a couple things happening here. We are tossing or flipping a coin. We are rolling a die. And so we want to find the number of outcomes um, in our sample space for this sequence of events. So if we have any number of events and each of those events has a different number of possibilities, if we want to find out all the possible outcomes for those events and their possibilities, we can just multiply all the possibilities together. So here we have a coin being tossed. So we have two possible outcomes for our coin, heads or tails. For our die, we have 6 possibilities, 1, 2, 3, 4, 5, 6. And so that would give us 12 possible outcomes. And we've talked about the tree diagrams previously, so this is not something you'd have to do. I just want to illustrate, sort of our 12 outcomes. When we flip our coin, we can have a heads or a tails. If we got a heads, then we could get a 1, we could get a 2, we could get a 3, 4, 5, or a 6 when we roll the die. If we got tails, we could get a 1, a 2, a 3, a 4, a 5, or a 6. And hopefully you can see that we have heads with each of the 6 possibilities, tails with each of the 6 possibilities, which leads us to our 12 outcomes. So I'm just going to do one more example of that. Here we have, and this should say wishes to manufacture. We're looking for all the different possibilities for paints, given these 7 different colors, 2 different types, 3 different finishes or textures, and 2 uses. So if we want to find all the possible paints that we can make, we take our 7 colors, our 2 types, our 3 textures, and our 2 different uses, and we can multiply all those together. And so we have 84 kinds of paint that we can make. Now, I would not recommend drawing a tree diagram from this, but you could see how we would have a red latex flat outdoor paint, or a red latex flat indoor paint, a blue latex flat outdoor paint, a blue latex flat indoor paint, so on and so forth. 84 different kinds using those 4 different criteria. Before we can go on to the next one, we do need to quick stop and talk about factorials. Hopefully, you've seen a factorial before. It sort of looks like a number yelling out loud with an exclamation point, but really this exclamation point is the factorial function. And that means to take whatever this number is and then multiply by each of the integers not equal to 0 below it. So 5 factorial is 5 times 4 times 3 times 2 times 1. 9 factorial, 100 factorial will be 100 times 99 times 98 times 97, so on and so forth. So this is just a way to write this big multiplication in a simpler form. And we'll note that 0 factorial is equal to 1. So here we have somebody who wants a 4-digit code for their garage door, and they want to make sure that they use different numbers for each of those 4 digits, and they're only going to use 0 through 3. So one of them will be 0, one will be 1, the other one 2, and the last one will be 3. So we can determine the possible number of outcomes when putting in this 4-digit combination by using 4 factorial, because for the first number we have 4 options, and then since we're not reusing, we will have 3 for the second number, and then 2 for the third number, 1 for the last number. So the last number is going to be whatever's left over, and so there are 24 possible 4-digit codes for this garage door. So I guess if you wanted to break in to this garage, you could just type in 24 possibilities. Eventually you would get one. And so that leads us to permutations, which is kind of the star of the lesson. The fundamental counting rule, we were just multiplying all the total possibilities for each event. Our factorial is just a review of the notation, because we're going to use factorial to do permutations. This is when we want to know, hey, what are all the possible arrangements if we have a certain number of things to arrange and we want to use some specific amount of those things? That seems pretty generic. So that's why I have an example here. This is the notation for a permutation, and this is what calculation goes into calculating that permutation. So n is the total number of things we have, and r is the total number of things from that group that we want to put in some order. So for example, we have 6 possible special guests. We want to select 3 of those 6 special guests to appear on our program. And in this case, order is important. And so what we have is 6p3. We have 6 possibilities. We want to arrange them in groups of 3. And so if I'm using this formula, I have 6 factorial over 6 minus 3 factorial, which we can simplify like this. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. Now, if you are good with your algebra or even arithmetic skills, you know that we can cancel some of these things out. We can cancel the 1s, the 2s, and the 3s, and we're left with 6 times 5 times 4. That's kind of like saying for our first radio guest, we have 6 options. For our second radio guest, we have 5 options left. And then for our third radio guest, we have 4 options left. So 2 ways to think about this that will get us to the same answer. There are 120 ways to put 3 of these 6 guests in an order to appear on our show. So let's do another one here. And I keep writing permutation orders matters because we will talk about combinations in the next lesson where order does not matter. And so it's important to determine which is which. So here we have 9 musicals to select from. And we need to perform 2 of them, one in the fall, one in the spring. And so if we use our formula, we have 9 factorial over 9 minus 2 factorial. And so we have 9 over 7 factorial. And so if you don't want to write out the entire factorial, that's okay. These two things have something in common, much like they did above here. Up here, we had the 3, 2, 1, 3, 2, 1. 3, 2, 1 is 3 factorial. Up here, we would have 7, 6, 5, 4, 3, 2, 1 for both of these. So I'm going to write it like this. And if it's confusing, that's okay. Just ask me to further explain it. I'm going to stop here because the rest of the numbers multiplied together times 7 is actually 7 factorial, which we have on the bottom, which we can cancel. And now we're just multiplying 9 times 8 to find there are 72 ways to choose 2 of these 9 musicals to present, one in the fall and one in the spring. Again, it's kind of the idea that we have 9 options for the first play in the fall and 8 options left over, and there are 72 ways. Sometimes we might have some of our objects repeat. So for example, if for some reason we wanted to figure out how many different permutations we have for the letters in the word statistics, well, we have some repetition. And so we have a different setup here. We still have n factorial on top, but on the bottom you see there's a bunch of factorials, and this notation might be slightly confusing, but what each of these R's is a repeated item. So R1 is our first repeated item, and R is the number of repetitions. I'm just going to say number of reps. R2 would be the number of repetitions for our second item, all the way till we get to our last item and that number of repetitions. So for example, our first item in statistics is the letter S. There are 3 S's. So R1 for us would be 3 factorial. We have 1, 2, 3 T's. We have 1A. We have 1, 2 I's. And then we have 1 C. And so these numbers, these R's, should add up to the total number of objects that we have, which is N. So we have 10 letters. We have some repeated, 3 S's, 3 T's, 2 I's, and then A and C are unique. They're the only ones. And so if we were plugging this into our formula, 10 factorial on top, we have 3 factorial for the S's, 3 factorial for the T's, 1 factorial for the A's, 2 factorial for the I's, and 1 factorial for C. And so we can do a little canceling here if we want to. We can use a calculator to calculate this. You could use Excel to calculate this. The function in Excel for factorials equal fact. And then in parentheses, you type the number you want to do factorial for. So whichever way you want to do this, if we calculated this all out, we would get 50,400 ways we could, or 50,400 permutations for the letters in statistics. So if you want some help putting this into technology, call me over and we can do it together. So as I stated in class, I don't want you to enter these into Edpuzzle in any way. I want you to try these, do them on paper, and then I want you to walk them over to me and show me what you did. Ask me any questions you might have. I will check your answers and we can have a discussion about any potential errors or misunderstandings that you might have. Take your time on these, and as always, if you need help, ask.